Welcome to Video 1, Section 3 of our Solutions 1 unit. Today we're going to talk about a chemical process called titration. It's something that we're going to use a lot in lab exercises. In fact, your first lab report, which is coming up at the end of this unit after the test, is going to be a titration experiment. So this is one of the most used lab activities in chemistry, and it's used a lot in industry to test different solutions. So we're going to define what titration is and some of the equipment, and then on subsequent videos we'll look at examples and we'll look at a diagram of how a titration works. The learning facilitator will also go over a short demo on how to use the equipment. So what is titration? Titration is a process in which a solution of one reactant, which we're going to call a titrant, is carefully added to a solution of another reactant using a piece of equipment called a burette. Now, a burette is a large graduated cylinder. And at the end of the graduated cylinder is a valve that you can turn, and it's called a stopcock. So it's a large graduated cylinder fitted with a stopcock at one end. And this allows a person to control how much of the titrant is going to be released into the solution. Another part of this process is we have to know when the reaction is over. And in order to do that, we're going to use a chemical called an indicator. And this chemical changes color. Due to the presence of a reactant or a change in pH. And that's what we're going to be relying on, a change in pH. And the indicator that we're going to use a lot has a very long, complicated name, and it's called phenolphthalein. I'm going to spell that for you here. That is how you spell phenolphthalein. And it is a solution dissolved in alcohol, and in an acid environment it is going to be clear. But as soon as the pH changes over 7 and becomes a base, it's going to turn a very bright pink color. And that'll be demonstrated by the learning facilitator when you are ready for this demonstration. So if we turn the page to our note packet, we're going to be talking about 2 points in a titration that are very important. So our first definition is for equivalence point. This is the point in a titration at which the moles of reactant added completely reacts with the second reactant. Or we can even say used up by the second reactant. The endpoint is the point at which the indicator changes color. And that is due to an excess of a reactant. So there's going to be a point in the titration in which we do not have any of one of the reactants left over because it has been reacted and made into products. One drop of substance past this point, the indicator is going to change color because we have one reactant in excess. And this is right past the equivalence point. So our goal of titration is to have these 2 points as close to one another. We cannot use an indicator to give us the equivalence point because at that point we don't have any of the reactants total. They both reacted together. But once one of them is completely used up and we add just a little bit more, we end up with an excess of one of the reactants and it causes a color change. It's almost like a limiting reactant problem that we went over in Chem 1. So our goal of titration is to have the endpoint as close as possible to the equivalence point. And this will be gone over in the demonstration. So the last 2 things before we conclude is we have 2 more definitions, a standard solution and a primary standard. So both of these are going to be used to help make our titration process be as accurate as can be. So whenever we have one of our reactants, we make a solution that we know the molarity of something to about 3 or 4 significant figures. And we're going to be using a lot of sophisticated equipment in order to do this, like an analytical balance. Our analytical balance goes out to 4 decimal place, to the 10,000th place. So we end up with a lot of significant figures. But we also need a substance that is going to allow us to determine the molarity of something very, very accurately. And we're going to make something called a standard solution. And this is a solution with an accurately known molarity prepared using a primary standard. And a primary standard is a highly pure chemical. And it has certain properties that make it really good. A lot of chemicals will react with the atmosphere. They'll absorb water from the atmosphere. It might not be very soluble in the solvent when you prepare the solution. So certain chemicals we use that are a little bit better than others. So this highly pure chemical does not react with the atmosphere, has a moderate formula mass, and is soluble in the solvent. So these definitions are going to be used in our next video on titration diagrams to explain this process a little bit more.